Hello and welcome. My name is Matthew Lin, a 20-year-old biology major at Cornell University, and today I'm going to be talking about bird flight. I first became interested in bird flight when I spent the summer at Shoals Marine Lab, which is a field station about 5 miles off the coast of Maine. I was walking around the island, and as part of my internship I was making a map of all the different landmarks. I had my walking stick, my radio, my GPS, my backpack, my notebook, and I was trying to get around as best I could. However, I was having a heck of a time. I was trying to jump over all of the cliffs, climb around all of the rocks just to get all of these landmarks. And I would look around, and I would see that there would be all of these birds around, but they would be having a much easier time getting around than I was. So I wondered, man, how the heck do these birds have such an easy time getting around? And then it hit me. Birds can fly. And so that leads me to the question of today: how are birds able to defy gravity? As a scientist, I can often feel like a detective, asking certain questions and then finding the right answers. I hope to answer the question, how are birds able to fly, by looking at 3 different things. The first would be wing shape, the second would be wing length, and the third would be feathers. So looking at these 3 things, let's begin. Now, science is all about asking questions and making observations. So let's start with the question, how does a hummingbird fly? So here we have a picture of a hummingbird, and what are some observations that you have? One observation you might have is that the wings are beating really fast. Now, let's make some observations on an albatross. What are some observations you have about its wings? What do you notice about the difference in wingspan? You might notice that the hummingbird has short, fat wings, while the albatross has long, skinny ones. The shape and length of these wings can be called the aspect ratio, in which long, skinny wings have a high aspect ratio and the short, fat wings have a low aspect ratio. So in general, birds that have long, skinny wings like to hold their wings out and glide, while birds with short, fat wings will flap their wings very quickly. Now, there is another way that we can look at wing shape, and that's by comparing a bird wing to an airplane wing. Both wings will look like this. What do you notice about their shape? You might see that one is curved on one side and one is flat on the other. However, you are just watching a screen at this point, and it's a lot more interesting to have something in front of you that you can hold. So at home, you can take any piece of paper and model having a bird wing. So we'll hold it just like this, in which we have a curved side on top, and then we can blow on it to pretend that we have an airstream. So from a side, we'll hold our paper like this, hold it up to our mouths, and we'll blow across the top of it. Now, before we do you have any predictions about what will happen? Okay, once you've made your prediction, hold the paper up to your lips and blow right across it, and we'll see what happens. Did you see that? We'll do that one more time. Now, I don't know about you, but I saw the paper go upwards when I blew across the bird wing. So now that we saw what happens, we can now describe why it happened. So what happens is that when we have air blowing across a curved surface, it creates a lower pressure, which then pulls the wing upwards. This is called lift, and birds use lift to help themselves stay in the air. However, again, this piece of paper is only a model, so now let's look at a feather. So here in my hand is a feather from the great black-backed gull, the largest gull in the world. So making some more observations, what do you notice about its shape? You'd notice that, like the piece of paper, it's also curved. Like a sail on a sailboat, feathers help catch air for birds to fly. Now here's another question for you. What if we say this bird gets into a fight, and then one of its feathers gets damaged? How well do you think the bird will be able to fly now? So you would notice that the feather, when it is torn like this, no longer is able to move. However, fortunately, like Velcro, birds can preen or adjust their feathers and put the individual veins back together, like so, and the feather is pretty much as good as new. However, this process does become a little more difficult if the feather is covered in oil, from an oil spill, for example. Thank you for joining me today. I hope that next time you're outside and you see a bird in the air, that you'll be able to better explain how flight is possible. I'm Matthew Lin of Cornell University, and I'll see you later. So we've talked about aspect ratio, and we've talked about feathers in general, but there is one more adaptation that helps birds to fly. And that adaptation, of course, would be hollow bones. So here's an activity all of us can do at home, but for me, I'm going to need some help. Matthew? So here we have the one and only R.A. Matt Lin with us here today. So as this final demonstration, what we'll do is we'll compare having a solid bone or a hollow bone. So what I've done is take 2 half-gallon cartons of milk and either filled one with water and then left the other one entirely empty. So what you can do at home is you can have the same setup, pretend this to be your bone, hold it all the way out in front of you, and once again try to flap your wings. You might find that the solid bone is quite a bit heavier than the hollow bone. So with hollow bones, birds are able to have a lightweight skeleton, so that way they can have an easier time staying in the air. Thanks, Matt.